With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, let's take a question. So here the question is that the dissociation of phosgene which occurs according to the given reaction to us, okay, it is an endothermic process. So which of the following will increase the degree of dissociation of COCl2, okay. So here we have the 4 points. Here we have the 4 points. So we will see each one by one. So first we have the reaction that is COCl2, and here we have is the formation of CO gas plus Cl2 in the gas form, right? So now we want to know that how we can increase the degree of dissociation, okay. So here it means that we want the reaction to be favored in the forward direction, right? We want the reaction to be favored in the forward direction. So here what happens is we have one concept that in the equilibrium, okay, equilibrium is the condition, okay, equilibrium is the condition, okay, it represents that state of the process when the properties we have like the temperature, pressure, concentration of the system do not show any change with the passage of the time. So here this reaction is at the equilibrium and we want to see that what should we add so that the reaction proceeds in the forward direction, okay, what should be the factors, okay. So here we want the reaction to be in the forward. So here first we have is adding the Cl2 to the system. Cl2 means that here this is, okay, this is the concentration of the product, right? This is the concentration of the product, okay. So here what happens is when, okay, according to the Lee-Chatelier principle, okay, we will answer this question with respect to the Lee-Chatelier principle. Lee-Chatelier principle is that when we have any equilibrium subjected to the change of whether it is concentration, temperature or pressure, it tells us about that in which direction the equilibrium shifts, okay, to undo the effect of the change which is imposed, okay. So whether if we increase the concentration of reactant or product, whether it will go in forward, backward, so it is all on based on the Lee-Chatelier's principle. So here when we have the increase in the concentration of the product, okay, when we have the increase in the concentration of the product, the equilibrium shifts in the backward direction, equilibrium shifts in the backward direction, okay. But when we increase the reactant concentration, it shifts in the forward, okay. But here we are increasing, adding the Cl2 which is our product, it will shift the reaction to backward, so it will not be our answer, okay, because we want to know which will increase the degree of dissociation, right? So here this will not be our answer. Next is adding helium to the system at the constant pressure. Now if we talk about the helium, helium is our inert gas, it is our inert gas, or we can say it comes in the category of the noble gases, okay. Here inert, here it is our inert gas, okay. So and the reaction is at the equilibrium and we have the addition of the inert gas at the constant pressure, okay. Then what happens is the equilibrium shifts towards a large number of moles, okay. In which direction we will have the large number of moles, the equilibrium will shift in that direction, the equilibrium will shift in that direction at the constant pressure on the addition of the inert gas. So here if we see, here on this side we have the 2 moles, here we have 1, so it means that equilibrium will shift in the forward direction, so this is correct. Now the next is decreasing the temperature of the system, okay. Next is our decreasing the temperature. So this reaction is our endothermic, this reaction is endothermic, and according to the Lee-Chatelier principle, exothermic are favored by the low temperature, endothermic are favored by the high temperature, okay. Exo are favored by the low temperatures and endo are favored by the high temperature. It means this is incorrect, this will shift the equilibrium in the backward direction, because if we decrease the temperature, that will shift in the backward, okay. Because favored, it means in the forward direction is favored by the high temperature. Now the next is our pressure, okay. Next is our pressure. So for the pressure we have is, if we have the low pressure, Okay, if we have the low pressure, then the reaction will be favored in the direction in which we have the increase in the number of moles. Okay, and if we have the same number of moles, then we will have the no effect of pressure. And when we have high pressure, it will be going in the decrease, where we have the decrease in the number of moles. So here what we did is reducing the total pressure. It means equilibrium will shift in the forward, because here this is our 2 moles are on this side, so this is also correct. So here our correct answer is option 2 and option number 4. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.